Hi, I wanted to go over some of the best practices for app development, meaning how do you design and plan and develop and support and maintain an application down the road. So some first things that we're going to talk about are the need for developers to actually sit down and begin coding right off the bat. This is what developers are. This is what we are. We have a tendency to code for first and then fix bugs later. And what happens when we do this, many new developers, especially iOS developers, start developing an app and then get frustrated, find a lot of bugs. They don't know how to fix them because we're missing a key important ingredient in our development process. And that ingredient is so big that I've developed an entire slide to spend on what that ingredient is. And here it is. So what kind of a plan? Well, we need a plan. A good plan for app development should at minimum include a list of what the app will and will not do, the niche that the app is going to fill, who's going to use it, why do they want to use this app and not some other? Because let's face it, nearly everything we can think of has already been done. If you have an app that has never done this particular idea, good for you. That's great. And you should do that and you should develop that. But you're going to need a plan for development. What data is going to be presented to the user? How will the app source the data? Who will do the user interface design of the app? Some user interfaces are very simple, but are there going to be graphics required? Is there going to be sound required? And who will provide these files for you? Are you going to do it yourself, or will you hire an artist to do that for you? And then you also need kind of a rough estimate of how long it's going to take to develop the app, but be prepared to at least double this during the development cycle of your app. A good plan, of course, includes goals. The first goal is to develop the app and make a lot of money. And that's a really big goal, but it's a start. But what I mean by goals are specific, measurable, attainable, realistic, and timely goals, manageable goals. So we divide the plan, after we have an outline of the plan, a rough outline, into manageable sections and assign each section a completion date. And these dated goals, we call them milestones. If a milestone slips by without its goal being completed, big deal. But go back and revise the plan and revise out all the other milestone dates so that you always have, during the development process, you always have a plan that you're working by. If something happens that changes the plan, go back and change or rewrite the plan. Once you have the plan and it's in a good kind of steady state, then you can begin designing your app. And I say here, now step away from mouse. Design does not mean code. Use paper and pencil. Draw out the classes that are going to make up that model and try to think of every way that the user is going to access data within your application. What's the model need to present about itself to the controllers, and how will the controllers get to the data that is in the model? What does the model need to know about the data itself? How does it manage its own data? And how is that data going to be organized? Is it within classes in your application? Are you using core data? Are you using SQLite? How will you manage and organize that data? And that is the model. After you have the model, or at least a good approximation or first guess of what that model is going to do, chances are this is going to revise your plan. So go back to the plan, change it, and then start working on the views. Put down the mouse. Draw out the views on paper, considering how the user is going to interact with the model. Don't think about flashy user interface design. That's not what designing views is about. Designing views is about having the user have a very intuitive grasp of what the data that underlies that app is all about. A good user interface is intuitive, obvious, and simple. Intuitive, obvious, and simple spell out iOS. If something in the design of the view drives a change in the model, go back and change the model. If that change in the model or the view derives a change in the overall plan or the milestone structure, change the plan. So after you have a model and the views, start gluing them together with controller classes. And remember that first rule of Model View Controller. The model and the views never talk to one another. The controller does the communication between the views and the model. Use delegation to inform the controllers of changes in the model and to pass information around from one controller to another. Use target action to trigger controller methods from active UI controls. If an app contains only one model, instantiate it from a single controller. Don't instantiate the model from two different controllers, because what will happen there? That's a recipe for disaster, because each controller will have its own instance of the model. If I make a change to the model in controller A, controller B won't have that change. So we only want to instantiate the model in one place. So this is called a master controller architecture, and it's a good guide for model view controller design. We might have a fairly complex app where we have a single master controller that connects to one model, and then we're using delegation from these controllers that aren't directly subclassed from that controller. But then we have this controller, which can communicate to this controller because it's instantiated within our master controller. Each controller has a view, and we might have a little model, a separate model, in this section of the application for this controller to drive this view. So we're still dealing with this overarching model view controller architecture that drives everything we do from a design philosophy in iOS. Now, you can pick up the mouse, sit down at the keyboard, and start coding. But once again, start with the model. Test the model under a variety of conditions, but test it using a single controller and log statements or printfs to get information out of the model. In IRS, remember that views and view controllers have to be written together. We use Interface Builder to do our views, but they need to have files owner, which is the view controller. So in order to do that, we really have to have kind of a well-tested model in place, so we're not going back and every time we do something we have to fix the model, or every time we make a change to the model we need to change the world in our view controller and view architecture. When you're testing, test not only for what you expect to happen, but try to test for things you don't expect to happen. For example, what happens if the user types in their name instead of some number that is meant to be inputted into only a text field? So what happens if I put alpha characters in that text field, and then we're trying to convert that to an NS integer or putting it into an NS number? What will happen? We should trap that kind of thing, and perhaps you didn't think of that when you did your user interface or within the model, so that's going to drive a little bug, and you're going to go back and fix that bug, but it only came up as a result of testing. In some ways, work is not really going to begin until you release the app. So before you release that app, make sure that you test the app using as many people as possible before you release the app. Family, friends, if possible, strangers on the street. Remember, you've got an iPhone or an iPad, and this is really neat. You can take that, put your app on the iPhone, and say, hey, I don't know you, but I wrote this app, and would you try it out for me? Or something like that. Tell your testers to be honest and critical about what you've done, because you can get some really good advice from users, and some really bad advice as well, from users that just sit down and use your app for a little bit. Be prepared to have an app rejected from the App Store, though, the first few times. Apple is critical, to say the least, about the apps that they post on the App Store. Not their content specifically, but how they're built. One big thing Apple does not like at all in an app is memory leaks. So make sure that your app is not leaking memory at the very least. Make sure you follow the human interface guidelines that are posted on the developer site with Apple. And there's some other guidelines that Apple, they call them guidelines, but they're really not. They're rules. And then once your app is accepted, now your real work and your fun is going to begin. So supporting and maintaining an app is a whole nother subject, but if you plan to support your app by providing bug fixes and updates and so forth, consider giving users a vector to comment other than the App Store. If you expect to read the App Store comments and feel all better about your application, wake up, because you're going to get good comments, you're going to get bogus comments, you're going to get some really bad comments. You need to filter these comments out very strongly. So what other vector am I talking about? Well, you could put a comment button within the app that just pops up the email interface with the subject and the 2 lines pre-populated and just says comment on my app. Also, you're going to get comments in the App Store comments. But if you get an actual email from a user of your app, chances are that if they took the time to do that and just not to scream openly on the internet, chances are that that will be a positive or at least helpful comment to you. Make ongoing bug support and updates a part of your plan. And I should have mentioned this earlier, but your plan needs to include update and maintenance support as well. You might consider making your first release a free beta with priced updates scheduled at regular intervals. Free beta releases on the App Store are not really a substitute for beta testing. So if you work for a company that is releasing apps, you will have a venue for beta testing yourself. But if you don't have that, consider this free beta approach. Make your app free and then price the first major release at 99 cents or $1.99 or so forth. In your mind, clearly distinguish between what is a bug and what is an enhancement request. They are two different things. A bug is a bug. It breaks something in your application. But there's good bugs and there's bad bugs. There are relevant bugs, I should say, and there's irrelevant bugs. A relevant bug would be your game crashes every time I level. You need to take a look at that. You need to fix that as quickly as possible because that is a game changer, so to speak. But an irrelevant bug is, hey, I took your pinball app on the space shuttle, well, into space now, and it doesn't work. Well, that's because your pinball app is using the gravimeter and the accelerometer, and guess what? It won't work. So the relevant bugs, you fix those as soon as possible. In the second case, it's kind of irrelevant, but what if you're marketing to NASA and you want to fix that bug? Well, maybe you need to do something. Maybe you need to simulate gravity in some way. But enhancement requests now need to be prioritized. You prioritize these on the basis of how much is it going to bring me or how much is it going to bring to the app, and bundle those up and put them on schedule in your plan for future updates. Always keep them wanting more. Don't fulfill all the enhancement requests at one time, because now everybody that wanted those enhancements is going to get the app and you will have no future sales. So always keep them wanting more means always keep the app in a state where it will continuously generate revenue until you have a better app that's out there continuously generating revenue, and so on and so forth. Thank you very much.